section 6.3, which is called complex fractions. Typically, when you hear about complex, people think complicated or hard or stuff like that. That's not what complex means in math. In this class, complex means one of two things. One thing that it could mean is we have nested fractions, or another way to think about it is when we have fractions within fractions. In order to handle this, there's a couple different ways to do this. I want to show you both ways, and I want to give you the opportunity to figure out which way you like better. So, first thing we'll do is let's start with an example. Let's say we had the example where we're told to simplify. And the problem is y plus 2 divided by y, all divided by y minus 2 over 3y. So like I told you, there's two different ways to do this. You don't have to know both techniques, just do it one way. So I'll show you method 1 over here. One way to handle a fraction like this is to simplify the numerator and denominator. And then we're going to divide by multiplying by the reciprocal. And then the last step is we simplify. Simplified means is that we leave the factor. So that's one way to do it. So simplify the numerator and denominator, which means we can combine, so we just get one fraction on top and the bottom. So let's just add that there. One fraction on the top and bottom, divide by multiplying reciprocal, and then we simplify. So taking a look at this particular problem, we have y plus 2 over y divided by y minus 2 over 3y. This is called a complex fraction because you have a fraction in the numerator, a fraction in the denominator, and the whole thing itself is a fraction. So as you can see, the top is just one fraction. The bottom is just one fraction. At this point, what we could do is just write it y plus 2 over y divided by y minus 2 over 3y. Once you get one fraction on top and one fraction on the bottom, you could write it horizontally like this. That takes care of the first step. The second step is you divide by multiplying by the reciprocal. So what we do is we say y plus 2 over y times 3y over y minus 2. That would be the second step. And then the third step is to simplify. When we multiply a fraction, we just go straight across. So this just turns into 3y times y plus 2 over the bottom would just be y times y minus 2. Like I said before, we leave it factored. You don't want to start distributing. You want it factored because we could actually cancel out a common factor here. Does anyone see the common factor that we could cancel out? Yeah, we could cancel out a factor of y on top and y on the bottom, giving us the final answer 3 times y plus 2 over y minus 2. Problems can get a little more complicated if we have to combine fractions in the numerator, but we'll start off with just a single fraction in the numerator and in the denominator. I call that technique 1. Let me go back a little bit and I'll show you another way we could do this. I'll call this method 2. If you like that first technique, great. You don't have to do it this other way. Some people like this other way. So for method 2, what we're going to do, first step is we find the least common denominator, the numerator, and denominator denominator. I'll explain what that means. For the top fraction, look at the denominator. The bottom fraction, look at the denominator. What's the LCD of those two denominators? Second step is that we multiply the numerator and the denominator by that LCD. And the third step is that we simplify. We just leave it factored. It might be a little quicker to do the second technique, but it's a little more advanced. Let me show you what that looks like for this problem. So we have y plus 2 over y divided by y minus 2 over 3y. What would be the least common denominator for y and 3y? We talked about this in our last class. The least common denominator between y and 3y would be what? Well, we need a factor of y. We also need a factor of 3. So the least common denominator for the top and bottom would be 3y. What we're going to do is we're going to multiply the top by 3y, and we're going to multiply the bottom by 3y. Let me show you what that does. You wind up with 3y times y plus 2 divided by y. That's the top. And on the bottom, you wind up with 3y times y minus 2, all divided by 3y. The reason why we do that, though, is look what happens. We can cancel this out with this. And we could also cancel this out with this. So all that you're left with at this point is you're just left with 3 times y plus 2 on top divided by y minus 2 on the bottom, which is exactly the same answer we got using method 1. Typically, when people teach this, they teach that second method. I think it's a little more advanced. If you look at it, I was getting a little bit of a headache just like looking at it for a little while. I think the first technique is easier to do. It's more work. The second technique's a little more advanced, but it's a lot less work. In one step, you get the answer. What do you guys think? How many of you like the first technique better? Yeah. What about the second technique? So at least you have two ways to get to the answer now. Let's just practice with a few more problems, and I'll escalate their difficulty a little bit. So, by the way, the difficulty level of your review guide is the same as what will be on your exam. So the next example, the directions are to simplify 4 minus 3 over x divided by 5 minus 1 over x. Another complex fraction. We have fractions within fractions. And I'll show you both techniques. This first technique, you want to try to get one fraction on top and one fraction on the bottom. So just looking at the numerator, what would the LCD? Looking at, well, the only denominator on top is x, right? So if that was the only problem, if we didn't have this other stuff there, we were just looking to combine those two fractions. What we would do is we'd multiply the 4 by x over x to get one fraction. What I'm going to do is just write a fraction. What I'm going to do is I'm going to multiply the 4 by x over x. And what that does is that gives me 4x over x minus 3 over x, which is just one fraction, 4x minus 3 all over x. The whole idea is you want to try to get the top to just be one fraction and the bottom to just be one fraction. Let's do the same thing with the denominator. We want to try to get a common denominator to combine them, and it looks like if we multiply the 5 by x over x, we get 5x over x minus 1 over x, which is just 5x minus 1 all over x. Now we have one fraction on top, one fraction on the bottom. So what we could do to finish this is multiply by the reciprocal. So 4x minus 3 over x divided by 5x minus 1 over x. This turns into, I don't want to write off the screen. This turns into 4x minus 3 over x multiplied by the reciprocal. X times 4x minus 3 divided by x times 5x minus 1 would give us the final answer of 4x minus 3 over 5x minus 1. Combine the top fractions, we combine the denominator fractions, and then we multiply by the reciprocal of the second fraction, dividing the fractions between. I'll show you that second technique. It'll be a little bit faster. Second technique was if we had 4 minus 3 over x divided by 5 minus 1 over x, what would be the least common denominator for the top denominator and the bottom denominator? Be 1x, right? So what we're going to do is we're going to multiply everything on top by x and everything in the denominator by x. So what that turns into, this would be, I'm just going to distribute this x here. So going to be 4 times x minus x times 3 over x, all divided by x times 5 minus x times 1 over x. Distributing that LCD to everything on top and everything on the bottom. This x and this x cancels. This x and this x cancels. You wind up with the same answer we got before. Let's keep going. What if I ask you to simplify? 3y plus 4 over y plus 1 divided by 2y minus 3 over 1. We'll try both techniques. First technique, I want to try to combine the fractions on top. Let me just write it again. So we have 3y plus 4 over y plus 1. What would be the least common denominator just for the top? So y plus 1. Yeah, this doesn't have a denominator, so we're just going to go with the y plus 1. What I'm going to do is I'm going to multiply this 3y by y plus 1 over y plus 1. And the top will just turn into 3y times y plus 1 over y plus 1 over y plus 1 into 3y squared plus 3y plus 4, all divided by y plus 1. What happens if we combine the top? In the denominator, we have 2y minus 3 over y. The least common denominator is the y there. We only have one denominator. We'll multiply this by y over y. And we'll get y times 2y over y minus 3 over y. This just turns into 2y squared minus 3 over y. We have one fraction on top, one fraction on the bottom. At this stage, what we could do is we could just multiply by the reciprocal. We have one fraction on top, one fraction on the bottom. And this would just be 3y squared plus 3y plus 4 divided by y plus 1. And we're going to divide y squared minus 3 over y, which is the same thing as 3y squared 3y plus 4 divided by y plus 1 multiplied by the reciprocal. When we multiply fractions, we just go straight across. So we're going to multiply y times 3y squared plus 3y plus 4 divided by y plus 1 times 2y squared minus 3. There's nothing that we can cancel out. There's no common factors. Because there's no common factors, we can't cancel anything. I'm just going to go ahead and distribute this to get our final answer. Final answer would just be 3y to the third plus 3y squared plus 4y divided by 2y to the third minus 3y plus 2y squared minus 3. That's using the first technique. Show you the second technique. Second technique is going to be a little shorter. So if we had 3y plus 4 over y plus 1, and we're dividing that by 2y minus 3 over y, trying to figure out what's the least common denominator for the top and the bottom. So we're looking at y plus 1 and y. What would be the least common denominator for those two? You definitely need a y plus 1 that takes care of the top, but you also need a factor of y. So what we're going to do is we're going to multiply everything on top by y times y plus 1, and everything on the bottom times y plus 1. And let's see what happens. So we're going to get 3y times y times y plus 1 plus y times 4 over y plus 1 divided by 2y times y plus 1 minus 3 times y plus 1 times 3 over y. Just multiplying the LCD times everything on top and everything on the bottom. And this will cancel with this. This will cancel with this. So just trying to straighten it all out, we're going to try to distribute now. 3y times y is just 3y squared, which will multiply by y plus 1. And we're going to multiply y times 4. On the bottom, we have 2y times y is 2y squared times y plus 1 minus 3 times 3 times y plus 1. I have an extra factor of 3 there. Let me just check this. 3 times y plus y times y plus 1 times 3 over y. That's what it should be. If we distribute it, we should wind up with what we got on top there. So it'll be 3y to the third plus 3y squared plus 4y divided by 2y to the third plus 2y squared minus 3y minus 3. This is exactly the same thing as what we got before. I know it's complicated. There's a lot going on here. have 4 more examples I wanted to go over. What if we had 5 over y plus 2 divided by negative 3 over y squared minus 4. Already one fraction over one fraction. So what we can do with this is using the first technique. We could say this is the same thing as 5 over y plus 2 divided by negative 3 over y squared minus 4. Which is the same thing as doing 5 over y plus 2 times y squared minus 4 over negative 3. If you multiply straight across, you get 5 times y squared minus 4 times negative 3 times y plus 2. This one's a little bit different though, because at the end we could still simplify this. It doesn't look like we can right now, but there's something else we could do to cancel out a common factor. Does anyone see what it is? Very good. So what we said in class is we could factor the top. The top just turns into 5 times y plus 2 times y minus 2. The bottom turns into, well, it stays the same. And we can just cancel out those common factors. The final answer of 5 times y minus 2 divided by negative 3. The other way we could do this, start from the beginning, 5 over y plus 2 divided by negative 3 over y squared minus 4. What we could do is figure out the least common denominator. What we'd have to do is just factor the denominator and it looks like the least common denominator would need a factor of y plus 2 in it and a factor of y minus 2. We get this one. If we were to multiply by y plus 2 times y minus 2 on the top and bottom, let's see what that would look like. This would be 5 over y plus 2 times y plus 2 times y minus 2 divided by negative 3 over y plus 2y minus 2 times y plus 2y minus 2. This cancels with this. These cancel with these. You wind up with 5 times y minus 2 divided by negative 3. Exactly the same answer. All right, you can. The directions were just to simplify. And what simplify means is that we cancel common factors. Does that make sense? So if there's nothing else to cancel, you're fine just leaving it alone. If you want to distribute it, it's not wrong. It just doesn't get us closer to the answer. Got this. 1 over A minus 1 over B divided by 1 over a squared minus 1 over b squared. First technique, we want to try to get the LCD. We have 1 over a minus 1 over b divided by 1 over a squared. In order to combine the top, the LCD of a and b. In order to combine those two fractions, we have to multiply by whatever factor is missing. Multiply the a by b over b. Multiply the b by a over a. That turns into b over ab. A over ab. B minus a over ab. Now we have the entire top, that's just one fraction. Just like you learned in middle school. If we're going to combine like 2 plus 1/3, you get a common denominator. That's what we're doing here with letters. The denominator, the least common denominator would be we need an a squared and a b squared. Multiply by whatever is missing. And we get b squared over a squared b squared minus a squared over a squared b squared, which gives us one fraction, b squared minus a squared over a squared b squared. We have one fraction on top, minus a over ab, divided by the bottom, b squared minus a squared over a squared b squared, which we can write as multiplying by the reciprocal. And if we were to go straight across, we get b minus a times a squared b squared divided by b squared minus a squared times ab. A couple things we could do here. Does anyone see something we could factor more? Bottom here. The b squared minus a squared, that's a perfect square. We could write this as b plus a times b minus a. This is a special case that we talked about. So this is factor. Top, we would just have a squared b squared times b minus a. Bottom would be a times b times b plus a times b minus a. We can cancel out a b minus a and a b minus a. We have a squared on top and an a on the first on the bottom. One of those cancels, one of the b's cancel. We'll wind up with just a b on top with b plus a on the bottom. Might scream when you see the second technique. It's a lot faster. But using the second technique, we have 1 over a minus 1 over b divided by 1 over a squared minus 1 over b squared. Hardest part is figuring out what is the LCD. So look at all the denominators. When we're trying to figure out the LCD between a and a squared, we go with the bigger of the two. So anyone want to take a guess what the LCD would be here? We need very good, a squared and b squared. Definitely need a factor of a, but actually need 2, so you go with a squared, and the same thing with the b. If you could figure that out, all we have to do is multiply the top and bottom by a squared and b squared. And multiply everything by it. And terms are going to cancel, and we'll get an answer very quickly. So let's see what happens here. A squared b squared times 1 over a minus a squared b squared times 1 over b divided by a squared b squared times 1 over a squared a squared b squared times 1 over b squared. What winds up happening is one of these a's cancels with one of these a's. So we just have a b squared. One of these b's cancels with one of these b's. So we get minus a squared b. In the denominator, this a squared cancels with this a squared. This b squared cancels with this b squared. That's what we're looking at right now. So we're almost done. We just always want to check to see if anything factors, if we can cancel anything out. So does anyone see something we could take out of the top? Any kind of greatest common factor there? Yeah, we can take out an AB from the top, and we're left with B minus A. The bottom, we talked about factoring. That's a special case. This would just be B minus A times B plus A. This cancels with this. We wind up with exactly the same answer we got before. The title of the section is complex fractions. I get it. It's tough. Like anything else in math, the more you practice, the better you'll get. Here's a couple more examples. See here. At this stage, they're all pretty much the same. Little slight variations. What if we had a to the negative second plus b to the negative first divided by a to the negative first minus 5b to the negative third. So we have negative powers. I have to try to remember, what did we say a negative exponent meant? Very good. All right, so we had a property that said a to a negative exponent, which means 1 over a to the n. In other words, we just switch the position. So in one step, this is going to be the same thing as the other problem. That step looks like this. We write 1 over a squared plus 1 over b to the first divided by 1 over a to the first 5 over b to the third. And now it's just like the other problems. So we'll do the two techniques. Or technique number 1. What would be the least common denominator for the top? For a squared and b, what would be the LCD? So we always multiply them. So we're going to have a squared times b. The least common denominator just for the top is going to be a squared b. What this means is if whatever we're missing, we have to multiply the top and bottom by that. 1 over a squared plus 1 over b. It looks like the top is missing b and a b here. And that second fraction is missing an a squared and an a squared. Which turns into b over a squared b plus a squared over or just b plus a squared over a squared b. Now we have one fraction on top. We'll do the same thing with the bottom. What would be the LCD between a to the first and b to the third? B cubed in it. So we multiply by whatever's missing. We just have 1 over a to the first minus 5 over b to the third. And we're going to multiply by whatever's missing. So we'll multiply this by b to the third over b to the third. And we'll multiply the b to the third by a over a. Which gives us b to the third over a b to the third minus 5a over a b to the third, or just one fraction. B to the third minus 5a over a b to the third. Now that we have one fraction over one fraction, what we do is we multiply by the reciprocal. So this is going to turn into b plus a squared over a squared b divided by b to the third minus 5a over a b to the third, or b plus a squared divided by a squared b times the reciprocal. Multiplying straight across, we get a b to the third times b plus a squared. And on the bottom, we get a squared b times b to the third minus 5a. You see anything that cancels? Yeah, one of these cancels with one of these, one of these cancels with one of these. So it looks like we're just left with b to the second times b plus a squared divided by a times b to the third minus 5a. There's nothing else we could do to cancel that. The second technique is more helpful. We we have 1 over a squared plus 1 over b divided by 1 over a minus 5 over b to the third. What would be the LCD? So we're looking for the highest power of each variable. What would be the LCD for every denominator? A squared, b, a, b to the third. The highest power of a is a squared and b to the third. So what we're going to do is we're going to multiply the top and bottom by that. Oh, do a squared b to the third times 1 over a squared plus a squared b to the third times 1 over b divided by a squared b to the third times 1 over a plus a squared b to the third times 5 over b to the third. And we'll look to cancel out our common factors. It should be there, I'm sorry. B to the third. This b cancels with one of these. This would be a squared b squared. On the bottom, one of these a's cancels with one of these. B to the third cancels here. In order to finish this, we just want to take out a GCF from the whole top, a GCF from the whole bottom, and see if we can cancel. We can take out a b squared, and we're left with b plus a squared. Bottom, we can take out an a. We're left with b to the third minus 5a, which is the same answer we got before. More problem for this section. What if we have x to the negative third plus 2y to the negative first over y plus 2x to the third. The problem on your exam that I made looks just like this. Okay. The thing we're going to do is let's just take care of those negative exponents. And just so you know, you can't bring these to the bottom. You're not allowed to do that because you're not multiplying. If you are multiplying them, you could bring it to the bottom. But because there's addition there, the only way we could write this is 1 over x to the third plus 2 over y to the third divided by y plus 2x to the third. This one might be a little bit easier because we don't have a fraction in the denominator. Let's do our first technique. First technique is we have to get the LCD of the top, which would be y. Very good. So we're going to multiply by whatever's missing in each of those fractions. So we have 1 over x to the third plus 2 over y. looks like that first fraction is missing a y, so I'll multiply by y over y here. And that second fraction is missing an x to the third. We wind up with y over x to the third y plus 2x to the third over x to the third y, which is just 2x to the third plus y divided by x to the third y. And the bottom doesn't change, it's just y plus 2x to the third. To finish this up, remember when we have one fraction, what we could do is write it sideways. We could just say this is the same thing as 2x to the third plus y divided by x to the third y divided by 2x to the third plus y. We'll kind of put it in the same order as the other fraction. Even though the bottom's not a fraction, we can make it one by just putting the whole thing over 1. And then when we multiply by the reciprocal, look what happens. Multiply straight across, wind up with just 2x to the third plus y divided by x to the third y times 2x to the third plus y. And what cancels? So you just get 1 over x to the third y. I'll show you that second technique. Looks like for this problem. Second technique, if we start from 1 over x to the third plus 2 over y divided by y plus 2x to the third, we don't really have a fraction in the bottom. So what we could do is we can multiply the top and bottom by x to the third y. We're doing the same thing we did before, but in this case, there's nothing on the bottom, which is fine. We wind up with x to the third y times 1 over x to the third plus x to the third y times 2 over y divided by x to the third y times y plus 2x to the third. What winds up happening is this cancels with this. You just get y plus the y's cancel, 2x to the third. The denominator, we just have an x to the third y times y plus 2x to the third. Same thing as we had before. We get 1 over x to the third